Hi everyone, in this video we're going to be looking at the Chapter 5 exam study prep questions, and I wanted to work through these together with you. We'll be doing these in class, but if you for some reason weren't able to attend class or want some more practice, I'm making this video and there'll be a template to go along with it in Canvas so you can follow along. Okay, so let's get started. I've got the problems kind of pulled over screenshots here to the side, and then we've got the template sections to be putting into the, we can do our work here. So let's take a look at these one by one. I'm just going to kind of pull these over and, no, that looks kind of funky. Let's just leave them over here. Okay, so in problem number 1, it tells us that a product is sold for $65 and it has a variable cost of $45 per unit. And the total fixed costs for the firm are $150,000. And if the firm desires to earn a pre-tax income of $90,000, how many units must be sold? So in a lot of these types of problems in Chapter 5, there's just kind of this normal methodology that we can work through with step 1, finding the contribution margin per unit. And in this problem, it tells us we have a $65 sale price, variable cost of $45, and then we need to know our kind of our formula for the cost, volume, profit analysis. And how do we get contribution margin per unit? It's taking sales revenue minus variable costs. And so that's kind of what we've got laid out here. So our contribution margin per unit is $20 per unit. And then it may not ask us or need this necessarily, but I think it's a good practice just to calculate the contribution margin per unit. So that's just taking, or the contribution margin ratio. So that's just taking our contribution margin per unit, divide that by the sales price, and we get 31%. So in essence, we're saying out of every $65 of sales, we're keeping 31% after accounting for the variable costs. And we have the rest of the 31% to cover fixed costs. Okay, and then in this problem, it asks us or tells us that we're trying to target a specific net income of $90,000. And so I've got that listed here as target net income. We've got our fixed costs listed out. And so if we want to figure out how much we need to sell to get to a specific targeted net income number, we need to figure out first, or we can do this all in one step. Let's figure out our break-even point first, because basically we figure out our break-even point, and then we just have to add in the number or the targeted net income on top of that. So if we're looking for the number of units that we need to sell to arrive at a specific net income amount, we're just going to take our fixed costs of $150,000 and we're going to divide that by our contribution margin per unit. So in other words, we would have to sell 7,500 units. So, and we kind of prove this to ourselves. So we take 7,500 units times the contribution margin. That should give us 150,000, right? So we're saying if we sell 7,500 units and each one of those units gives us $20 after accounting for the variable costs, then that will leave us in total with $150,000, which would exactly cover our fixed costs and bring our net income essentially to zero, which is what we want. Otherwise, it would be negative. But then if we want to target a specific net income on top of that, we just need to add in not only which one did I do? Let me delete that out. Not only the fixed cost here. So here is our formula to get break even. We just said fixed cost divided by margin per unit. But then let's add our extra 90,000. I'll just link to the cell here. And now we're saying how many units do we need to sell to cover our fixed costs, and then on top of that earn us, leave us with an additional $90,000. And so we take our fixed costs plus our target net income, divide by contribution margin per unit, And we can see that leaves us with 12,000 total units need to be sold. And I have this little line here. Actually, we could add that together. So really what we're targeting is a total of 240,000. And if we wanted to just do the formula that way, we could say, which is the same thing. We just said this plus this, but we also added it here just to see it more clearly. And so again, just to kind of prove this off to the side, we take 12,000 units and we're earning $20 of contribution margin per unit. That gives us $240,000 after accounting for variable costs. And then the fixed cost portion is just 150. So if we took the total minus the fixed costs, it would leave us with that $90,000 target net income. All right, let's look at problem number 2. So this tells says a company, we're looking at 2 alternative methods of producing a product, and the below information about the 2 alternatives is available. If the company's expected sales are 25,000 units, which alternative is more profitable? So we've got 1 and 2 alternatives, and then we've got cost per unit, variable cost per unit, fixed costs, and then we've got selling price. So 2 different selling prices basically. So we've got some of this information already kind of plugged in here in our little template. So our fixed cost there, our variable cost, selling price per unit. And so one of the first things here, we can just get contribution margin per unit. And remember, like we were talking about here, from our previous formula, to get the contribution margin per unit, you just take your selling price minus the variable cost. So $15 contribution margin on alternative 1, and the same thing on our alternative 2. So it's different costs and selling prices, but comes out with the same contribution margin. Okay, and then to get our contribution margin percent, we're going to take our contribution margin divided by the total selling price. So we had 50% and then 60%. And let's see here. And then our expected sales, it tells us, is 25,000. And what we want to figure out is which is going to be more profitable overall, right? So if we know that we're getting $15 of contribution margin per unit times our expected sales, then we're going to get 375,000 under both scenario because they have the same contribution margin per unit. But then we've got a different fixed cost. So we've got 175,000 in alternative 1 and 100,000 in alternative 2. So if we take out the fixed cost, then we can see that alternative 2 is the more profitable pathway to go. So, and it's not always as, you kind of have to look at the data. It could be varying in different ways, but the overall gist is just to be able to get, contribution margin per unit, know that we multiply that by expected sales in units to get our total contribution margin, and then backing out the fixed costs, which is the other portion of costs. You got your variable and fixed to arrive at an overall net income. All right, let's go down to look at number 3. So in problem number 3, it tells us that the company is considering the production and sale of a new product, and we want to figure out what the break-even point in units and dollar sales is going to be here. So we figured out units, break-even, or actually, we did figure out break-even point, but then we also added in a target net income above in problem 1. And in this problem, we're just going to have to figure out break-even point, but we're going to do it in total dollars and in number of units. Okay, so first thing, let's figure out our contribution margin per unit. So easy, we just take sales price minus variable cost, gets us $60. Then we're going to go through and take our contribution margin per unit divided by the sales. the sales price to get the contribution margin ratio. Now, if we're doing a break-even point, what we really are saying is that we're targeting $0 in net income. We're just breaking even. We're just covering our fixed costs. So if we wanted to think of that in terms of a target net income plus fixed costs, really that target net income is just a 0. Up here, target net income was 90,000, so that's where we got a bigger number for this. But if we're just trying to figure out what that break-even point is, then we're targeting $0 in net income. Okay, so let's do the units first. That's kind of, maybe it's easier. I mean, they're both simple calculations, but we did this one before. So we're basically just taking our fixed cost divided by contribution margin per unit. So 2,100, and then we can kind of prove that to ourselves. You know, if we have 2,100 units sold, we're earning $60 of contribution margin per each one of those. That gets us $126,000 to cover fixed costs, which exactly covers fixed costs to get us a 0 net income. So that's the break-even calculation. And then in terms of doing the same thing, but coming from a perspective of total sales revenue needed, we just take our fixed costs divided by our contribution margin ratio, so divided by 40%, and that gets us $315,000. And then again, to kind of prove that to ourselves, so if we had total sales of $315,000, and we had a 40% contribution margin ratio, so after variable costs, we have 40% left over for fixed costs. That 40% then, you know, is exactly the $126,000, which covers our fixed costs to the penny, right? I mean, this is all, and again, this is an art, not a science. It's more of a budgeting and estimated managerial techniques. But in terms of our calculations, that's to the penny of getting us to what the fixed cost would be and leaving us with 0 net income, which is the definition of breaking even. So again, the key things are figure out contribution margin per unit, the contribution margin ratio, and then know that we just need to divide by contribution margin per unit to get the number of units and divide by the ratio to get the total sales dollars needed. Okay, let's take a look at problem 4. I'm going to scoot some of these up here so we can kind of, I'll just pull this up so we can see it. So problem 4 says XYZ company, we're considering sales, production, etc. So we've got some sales price per unit, variable cost per unit, and total fixed costs. And we need to figure out the contribution margin ratio, break-even point, and then if we want to get a pre-tax income of $210,000, what would we need to, how much would we need to sell in dollars? Okay, so first thing, again, let's just figure out our contribution margin per unit, and let's figure out our contribution margin ratio. So our CM per unit divided by sales price, so we get 35%. So the first one, our target net income, we're just going to do 0 because we're just trying to figure out the break-even point. So we have our ratio, we figured that out. Now the break-even point in dollar sales, again, is just going to be whatever our fixed costs are. And so we can take our total, and I'm going to do it like this. Let's have two different. I'm going to link to our fixed costs divided by our contribution margin ratio to say we need to sell $1.5 million of product to leave us with enough contribution margin to cover our fixed costs there, right? So if we have 1.5 million, just to prove this, 1.5 million in sales times our 35% leaves us with 525. That would cover our fixed cost to break even. But now if we're saying we want to achieve pre-tax net income of $210,000, so that's our targeted net income, we basically just take our same formula again, similar to what we did in problem 1, but instead of just using the fixed costs, we're going to, or I'll just link to our cell here, we're going to take the fixed cost plus our targeted net income. So that tells us we need 2.1 million in sales to net us $210,000 in net income, right? And to prove it, right? So we say 2.1 million times the 35% gets us 735,000. And then if we take out the fixed costs, that leaves us with the 210,000. And that's what we're shooting for. Okay, so pretty similar to the other problems there. And yeah, just a little practice, nothing too hard from a math perspective. Okay, let's look at problem number 5. Again, just similar types of problems. A lot of these in chapter 5 in general. So problem number 5 says a product sells for $300 per unit, variable cost of $150, fixed cost $420,000. If we want to earn $60,000, how many units must be sold? So let's just kind of walk through this same process essentially. And sorry, let me delete out some of these. Whoopsie, I had left these in. Bear with me. I'd rather have them empty so we can do them together. So, so in product 5, we have $300 of sale price. Variable costs are 150. So 300 minus 150 gets us 150. So we can already see probably what that 50% contribution margin ratio. We see our fixed costs are 420,000. And our target net income is 60,000. So let's add those together. And then the sales revenue that we would need to, and it doesn't ask us this specifically, but let's just do it for the heck of it. We would take our total target net income divided by our contribution margin percentage. And so we would need 960,000 in sales to be able to cover our fixed cost and leave us with 60,000. But if we want to answer the question here and say how many units, then we take our target net income divided by the contribution margin per unit, and that would be 3,200. Okie dokie, so let's look at problem number 6. So this one, problem number 6 is a little different, but we can kind of use our logic here that we've developed so far. And we'll be missing a little bit of data, but we can still answer the problem regardless. So it tells us we have 45,000 in fixed costs. We've got contribution margin ratio of 36%. So this problem already gives us the ratio there. We have expected sales of $200,000, and we want to know what's the margin of safety in dollars. So to figure out our margin of safety, then we would want to figure out how much are we above our break-even point. Basically, that's our margin of safety. So if we're saying we want to figure out our break-even point, then again, we can have let's target $0 net income. We know what our fixed costs are. So again, really, we're just looking at fixed costs. And so, excuse me, to do a break-even point analysis, then we just take our fixed costs divided by our contribution margin ratio percent. So that gets us 125,000. And I'm going to have this say margin of safety. And so then our margin of safety, because we have expected sales of 200,000, then our margin of safety is just the 200,000 minus the 125,000, or 75,000 basically. So what we're saying there is we have $75,000 in sales before, that can be reduced before we get to the break-even point, and then if it keeps reducing below the break-even point, then we would potentially get into a net loss type of scenario. But for our purposes here, if we have those expected sales that we're earning, then we've got that $75,000 margin of safety. Okie dokie, let's take a look here at number 7. Pull it up here. So number 7 says a product sells for $225 per unit, variable cost of $125. So that means our contribution margin is $100, and the ratio is 44%. Okay, so we would just want to know what our break-even point in dollar sales is going to be. And we've got fixed costs of 320,000. So again, if our target net income is just 0, then to get our sales revenue needed, we would just divide by our ratio. And to get our number of units, we're just going to divide by the margin per unit. So 3,200 and 720,000 would be our totals. And this one just asks what's the break-even point in dollar sales. So we didn't necessarily need to get the number of units, but I just like working through these so you all, because sometimes it'll ask one or the other. So I figure more practice, the better to get comfortable with this this process. Okay, so problem number 8. We've got $3 in sales price, $2.25 variable cost. So that means our contribution margin is 75 cents per unit. Again, we'll just get our ratio there, 25%. We're just doing break even, so no, zero target net income. We got 11,250 fixed costs. So let's add those together, and then this one's asking how many, but again, we can do the same kind of thing and say if we were looking at dollar sales, we would need 45,000, but if we're looking at units, by dividing by the contribution margin per unit, we would need to sell 15,000 units, which would earn us, our total sales revenue of 45,000, right? And just like proving it out, 15,000 times 3 is the 45,000, right? So that's the same thing we're kind of saying here. It's just in different terms of whether it's number of units or total sales revenue from selling those units, essentially. Okay, that's all the problems on this first page. Let's look at 9 and 10. I just have a couple more problems to work on here, and these look at the high-low cost analysis process. And let me zoom out just a little bit. Okay, so I've got problem 9 here, and problem 9 tells us, or it asks us to use the below information here for XYZ company, and we're going to use the high-low method to figure out the variable cost per unit, and then we're going to use that to figure out the monthly cost, the monthly fixed costs, and then we're going to assume kind of a forecast of if we produce 2,300 units, what is going to be our total expected costs based on the analysis from chapter 1 and 2. Okay, so to figure out, to do the high-low cost analysis, the first thing we want to do here is to take the difference. So we look at our data set, and we can see here, let me zoom in a little bit. So for problem 9, and we'll do problem 10 next, but I'm just going to pull this over for now. Okay, so what we want to do is first figure out the difference between the high and low month cost months. And so the highest cost month here is the 65,000, and then the low cost month is 27,000. I'll put a minus on this so that we can see the difference between those is 38,000. And then the difference in those months from a unit perspective is 2,000 units. That was the high cost month there, and then the low cost, the number of units produced. And then we just take the cost difference, so that 38,000, and we divide that by the unit difference to get a number that kind of tells us, an estimate for our variable cost per unit then is $19, right? So we're saying basically if we increased in production a whole bunch, or costs at least from a cost perspective, we did increase production and cost went up this much from this. Basically the theory here that we're trying to implement is a $38,000 increase in cost based on an increase of $2,000 in production. So therefore, per unit, then that increase in the cost comes out to $19. And then we can go back using this number. We can let's go to our high month in our units, take our variable cost per unit, and just multiply those together to basically say, okay, our total variable cost is $57,000 if we're calculating out $19 per. Oh, sorry, I should do this. Total cost is $65,000, and then less the variable costs. Gets us fixed cost of $8,000. And then that would be consistent, month over month essentially. And if we're going to say we estimate production of 2,300 units, again, using our variable cost per unit, we can estimate that that's going to be 43,000, or sorry, let me do it like this. So $19 variable cost per unit, which would give us total variable cost of 43,700. And then we add in our fixed costs like we did above. And that would bring us to 51,700 expected total costs, including the fixed portion and the variable. And we figured out what the variable was by taking the high and low differences. And then we figured out what the fixed cost portion would be by taking the total costs minus the variable that we figure out using that variable cost per unit. Okay. So for problem number 10, very, very similar problem. And I'll scroll over here. Let's just kind of run through this again. It's going to, like I said, be a very similar outcome. But let's look at our high and low month again. So our low cost month here again is September, and our high cost month is June. And so we're going to take our high cost minus our low cost. So the difference was 51,000. And then we're going to take our high units minus our low units. So 3,400 unit difference. And then we'll take the cost difference divided by that unit difference to get us a $15 variable cost per unit. Then we're going to go back up to our units produced, take that variable cost per unit to get our total variable costs. And then we'll take the total costs, including variable and fixed, subtract out that variable portion. And again, this is from the high month. So we just, that's what we're getting all these numbers from. If we back out the variable piece that we figured out using the estimated variable cost per unit, we end up with $7,500 in fixed costs. And again, then using that information, if we estimate that we're going to have 2,500 units in October, what's our expected cost? Again, we can use the $15 variable cost per unit, multiply those together, and then we'll add in our fixed costs. Add those together. And remember, the fixed costs are going to be the same every month, regardless of production, right? So no change there. The only thing that changes, based on our production, is the variable piece, which we figured out above. And then, add in the fixed portion, arrives us at 45,000. And that's how you do the high-low calculation. So, practice those two problems. If you practice all the problems, you're going to be really well prepared for the exam if you feel comfortable doing all these. And like I said, I'll leave a blank template that you can kind of follow along and then test yourself. I would, if you really want to prepare well, follow along with me if you're stuck on any of these. Make sure you get the right answers, and then maybe go back through yourself and calculate them out without the video and see if you can arrive at the same answer without my assistance. And if you can, then you're going to be in a really good position for the preparation for the exam. So, well, thanks everybody. Hopefully good luck studying, and hopefully you all do well on the exam. All right, thanks. I'll see you in class.